Hello, hello, and welcome to another stream. So, um, yeah, today will be another compiler stream as always. And today I want to do something fun because last time was a bit boring because we just did a whole lot of refactorings and didn't actually add new features. So this will change today. We will implement one new feature, which is actually quite nice. And the goal for today is to make functions expressions, right? So you can just use functions as values, and actually for now only as values. So we will not have any top-level function declarations anymore as we do right now. So what do I mean by that? Right now, when we want to declare a function, we declare it like this, right? So we say func, then the name of the function, the parameters, and the return type, and then the body of the function. And this is nice, but what if we want to have a function that takes a function as an argument? So something like, I don't know, what could we do? We could say like, yeah, something like this, all right? So we want a function that takes an integer and returns an int. So right now we cannot do that because our functions are not expressions and not even statements, but just items that live in the compiler. And to change that, we will have to make functions expressions. And what my plan is for that is that we remove these function declarations altogether. So instead of having an add function like that, we will declare functions just like variables. So we will say something like let add is equal to func, then the parameters and the return type, and then just a normal function body. So this is actually pretty neat because then we can introduce a function type which has the signature of, for example, in this case, first parameter is an integer, second parameter is an integer as well, and the return type also. And then we can, for example, declare another function like I don't know, test equal to func, and we can just say like another func, and this will then take in a function that accepts two ints, returns an int, and then we can, for example, just call this function with 1 and 2 as the arguments, and this will then be evaluated to 3. So I think that is a pretty cool feature, and it will actually not even take that much effort to implement this. So let's get started, right? The first step, as always, is to adjust our AST structure, and then we will go onto the parser and actually change the parsing, which is not that much to do there because we just have to remove like this keyword, this identifier in between the func keyword and the opening bracket, and then we have to adjust the evaluator. So first step, AST. So right now you can see our AST consists of statements, expressions, and items. So right now an item is either a function declaration or a statement. So what we can do now is we can delete this func from here, and now our only item that we allow is a statement. So why do we even have or keep that item if the only item is a statement? I mean, just imagine in the future we will probably add something like classes or structs, and we probably don't want structs to be or struct declarations to be values, because that does not make too much sense, right? Because a struct is basically just a blueprint, so it doesn't really make sense to have that as a value. in the programming language. But what we can do now is we can search for our expression kind and add a new expression here. So this will be func and for function expression. We need to derive from debug and clone, and we'll say func exp, and this will for now just take a function declaration. And we will have to adjust this function declarations, right? Because we won't need an identifier anymore. So we can just remove this, and then we have to adjust our factory method here. So instead of returning an item, we want to return expression here. And we will actually rename this to func exp. And we will not need a token anymore. And this will be an expression kind, and we'll use the exp from kind method. So this will take a func exp, which will take a declaration, and we can just remove this identifier from here. And now we have to add the span method for our func. I guess for now this could actually just be the func token, right? Yes, I guess we could do that. But we don't have the func token or keyword as of right now, I think. Yeah, we don't. So what we could do is we could add that to our declaration. So this will just take a func keyword, which will be of type token. And now in the span function, we can actually just return the span of any keyword, or func keyword in our case. And we have to clone that because we expect an owned text span here, which is not optimal, but I guess we don't really care about memory for now. So now we have to add that to a factory method, which will now just take a func keyword token, which we then can pass onto our function declaration. And so we're actually done with the AC modification. So now we can move on to the parser, and then eventually we will have to adjust our AC visitor and our evaluator. So first step, parser. So we will go to parser.rs, and you can see that our parse function declaration returns an item, but because function declarations will now be expressions, we will actually return an expression from here. And we will also rename this method to parse func exp. And actually we don't need an identifier here anymore. And because we will parse this as a primary expression, no, primary expression, as you can see here, parse primary expression, it consumes the token. So the first token for a primary expression will also always be passed in as an argument in the method. So we have to go back to our parse func expression, and this will now take an extra argument called func keyword, so we can pass that from the parse primary expression function. So we can also remove this consume and check token kind func, because this is actually the keyword that is passed here, so we don't have to check that anymore. And now instead of passing the identifier here, we can just pass func keyword. And now, because in the parse item, we still expect that when we see a func keyword, we want to parse an item, which is not the case anymore. For now, we just always want to parse a statement, right? So we can just remove any additional checks here. And actually, what we now have to do is we have to go to parse primary expression and check and say, if we encounter a func keyword, we will parse a func expression. Parse, I think I named it parse func expression, right? Parse func expression. Right, cool. So now we can parse func expressions. But the problem is that we can't really do anything with those func expressions because we can't call them. Because how our call expressions are parsed right now is that if we encounter an identifier, we say if next token is a left parent, so that means that, for example, something like this. So we have a function identifier, stuff like that, and then if we encounter our next token, or if the next token is a left parent, which is this character, then we know, okay, we should call, or this should be a function call. But that is not actually how it works anymore. Because what we can do now is we can have a complex expression before that, like, I don't know, some expression that evaluates a function value, and then we can call that, right? So I don't know, what you could imagine is if we if a function is an expression, we could just say something like this. And now this is not an identifier, right? It's just an expression that evaluates a function. And this will actually be valid if we parse this correctly. Because right now our function body is also a statement, but we will change that to also be an expression. So we can just say 1 and it will evaluate to 1, which is kind of cool, I guess. And but it could lead to some very weird syntax. So instead of parsing a call expression here and having an identifier as the callee in our call expression, we will also have to adjust our call expression, right? So, call expression. This will now not be an identifier anymore, but much rather something like a callee. And this will be an expression. And because we're already in our AST file, we can also adjust the body to not be a statement anymore, but to rather be an expression. So we will place it with an expression ID. So this will break some things, I guess. Yep. So we have to change this one as well here. And I think the call expression will also be broken, right? Yep. So this will not be an identifier anymore, but a callee, and it will be an expression ID. And we will also have to adjust the span composition of the call expression, where we can just say this will be the callee span, and that we will compose that by querying the span from our AST. So we will say query expression callee, and get the span from that. And right, we don't want to visit a statement here anymore, but an expression because our body is now an expression. So next up, back to the parser, I guess. So here we don't want to get an identifier anymore, but the callee. And so we will not take a token here anymore, but an expression. Callee of type expression ID. So this will give us an error when calling, I guess, because we pass a token here. And because, as I just explained, we don't want to just parse a call expression when we encounter an identifier, we can just remove this and just always pass a variable expression. But now what do we have to do? We somehow have to figure out when an expression is called, right? So if we evaluate an expression and then there's like a left parent and right parent, and this expression should be called. So how can we do that? I guess we could save this expression here. So we could say let x is this expression. And then we could say like match self current dot kind. If we encounter a left parent, then we will parse call expression. We will say return this and say what do we want to do here? I'm gonna say self parse call expression. Call E will be expression.id. And else we will just return our expression. So this should work because we consume our left parent here, so we don't have to consume it before we call this function. And what else do we have here? Okay, so we don't want to parse a statement here, but rather an expression. And we can actually rename this method to parse x because we're cool. I don't know. Right. Okay. So this has to be an ID. Yeah. Okay. This seems to work. So maybe let's just write an example of what we want to achieve in our test program here, so we can check if everything works as expected. So what we want is something like let add is this. So that should just now behave the same as it did before. And if we run this, we should get compile errors. Right, okay. Okay, that makes sense. So we have to change our like symbol lookup logic a bit, because now we don't actually want to look at a function directly by name, but we kind of like want to create a function symbol when we encounter a function expression so that we can reference it later, right? But we don't actually want to have like a symbol table where a name of a function is mapped to an expression ID, and the expression ID being the body of the function that should be executed. But much rather the function, like the function index or ID that we have right now, should be passed to the type of the function. Like we will create a new type variant to our type enum. Let's find that. Wait, where is it? Typings. Here, right. So in our type enum, we will have another type called function, and it will have a function index. So a function index is used to uniquely identify any function that we create during the compilation of our program, right? And we could, of course, we could just pass like the whole function signature in here, but that would like be very inefficient, right? Because we derive clone here, so every time we clone the type, it would also clone a whole bunch of memory, and that's not even the biggest problem. The biggest problem is that if we now have two instances of our function symbol, and for example, I don't know, we want to modify the return type because we in the future add, I don't know, something like the Hiltny-Milner type resolving algorithm, which will actually like create a bunch of constraints and then set all the types. And we want to change the return type of the function, and we change it on one instance, so like one function that lives somewhere in memory, then only that function's return type will change. But in the cloned variant, it will not change and it will still be the old value. And for now, we will just say function here. We will probably have to step away from implementing display for type, because we now only have a function index here, which does not actually contain any metadata about the function signature, right? So we will have to pass in our global scope, which holds all the actual information about our symbols, so that we can actually like format it properly to say something like this, and then like int blah blah blah, however we want to format it, right? And we will also have to adjust these two methods, or not, actually this one we will not have to adjust. We'll eventually have to figure out another way of parsing types, right? Because right now every type signature is also just a single identifier, right? It's just int, bool, and void. But an identifier or type annotation for a function actually consists of like open parentheses and other types in between those parentheses and the return type, and so on and so on. So we will have to adjust that as well. But we will not do that now. We first just want to get like basic stuff working, right? So where were we? I think we need to go to our visitor probably. Oh no, we were at span resolving, right? Oh no, actually I was just explaining about why we don't need like function symbol tables anymore. Right, so we can actually just remove this function method because we will not ever need this anymore, because we will not look up any functions by name anymore. So we can also remove this, and because we don't return any arrow here, we can also just remove this result return type and just make it return probably something like the function index, which is returned by our push method. And we could probably also rename this to create function, because we don't actually declare a function, but we rather create a function and store it in our scope. So we also have to adjust this, because it would not take an expression ID and it will not take an identifier anymore. And that means we also have to adjust our function symbol, which I will actually rename to function. We don't need the name anymore, so function, no name, and body will be an expression ID. So look at function, you can also remove that. Bit of function declarations, blah blah blah. Okay, so right now we have this global symbol resolver, right, which walks the AST and looks for any function declarations. But because we don't have that anymore, we can probably actually just remove that. We will eventually need that, like if we implement structs. But I think we can come up with something better. So yeah, let's just remove it. Cool. Now, instead of creating functions when like in a separate pass, we have to create those functions when we actually like visit them during resolving or type resolving. But for that, we first will probably have to adjust our AST visitor to actually provide all the information that we need. So because right now the signature of our visit function declaration method is not correct, because it should actually be visit func expression, and it should probably take in a func expression. We can probably also rename that func exp, and that should be a func exp. And we want to take in, like, I don't know, the expression ID. So Rust reminds of Rust's exhaustive pattern matching reminds us that we have to specify what we want to do if we encounter a function expression, which will be very similar to all of the other stuff here. Just visit the function expression. And what we could actually do, not right now, but in the future, what I was just reminded of because I just specified an ID here instead of the expression, is that we clone our expression here, right? Cloning is generally like bad. And this is because otherwise we would run into issues with borrow checking, right? Because our AST is borrowed immutably here, and it is borrowed mutably here. So we can't do that. But if we, instead of cloning the expression, we only clone the ID, we like save a lot of memory space. And this, we can do that because the only thing that we use from those expressions that are passed into here is the ID. And even if we need something else, we can just query the expression, right? Because we have the ID in the AST. But we will not do that for now. And now visit item, we can just remove that. And because we now only have the statement. AST evaluator, okay, we will do that at the end. So, where is our compilation unit? Right, okay. So this will be a func expression, func, blah, 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 func exp, and expression ID, exp ID. And now, instead of looking up a function by identifier, what we will do is we will actually create the function. So we will say self scopes, global scope, create function. And we have everything that we need, right? So create function takes an expression ID, the body, parameters, variable indices, and a return type, which we all have. So first step, body. Pretty easy, right? We just say func decal statement, which we can actually name to func exp, and we could probably also say something like let decal is func exp decal. Oh, right. So this could actually probably. So we can declare it like just a reference to our declaration, so we save a little bit of typing because we will need that declaration quite a bit in here. And we can say decal at body, and we can. Oh. Okay, so actually just a reference will be enough here. Next argument, parameters. So this one is a little bit more complicated, but still manageable, right? So we can say let parameters will be decal parameters dot, and we will use the iterator. We will map over our parameters. So we say parameter, and we will. What will we do? We will create a variable, right? Because we expect a vector of variable indices here. So how do we do that? We say self scopes declare variable, right? And declare variable takes in an identifier and a type. So our identifier will be parameter identifier, and it's actually a string. So span literal. Oh, we'll need a string reference here. And the second one will be the type, which will be resolve type from string, which we have to pass our diagnostics. Diagnostics and our type, right? So this will be type annotation, type name, and probably a reference. Yep. Okay, cool. So now we have a type, and this can now declare this variable and return type or return value, which is a variable index. And just like that, we're done. Now we just have to collect the vector. And now we can pass our parameters here. So now we just need to pass return type. So we can say let return type is also resolve type from string. Type. Wait, is that also not public? It is type name. Okay. Type name. Oh, because it's an option. Right, okay. So we have to map this. So we say declaration return type dot as a ref dot map. So we say like syntax here. And we say resolve from string, and we say syntax type name, and we say unwrap or void, right? Because if we do not have a type or return type declaration, we want to set the type return type to void. and now we can pass the return type in here. Cool. So I guess this should work. Clear variable, create function. Right, and now we don't have to choose a statement here, but much rather an expression. And we can also use our decal here. Decal exp body. Yeah, it's called body, right? Okay. So, I think we're good. Right? Yeah, I guess. So, now to call expression. So, we cannot actually look up a function here. Right? Because we now don't have an identifier anymore. But what we can do to obtain this function is we can say match exp dot type, and we can say if this is of type function, then we will return some function, else we will return none. Oh, none, and we will have to copy this. So now we have access to the function. Cool. And now instead of reporting we encounter an undeclared function, we will report that we cannot call something that is not a type function, right? So we will rename that to report cannot call non-callable expression. And we will parse span here, which we can obtain by querying the expression and then saying span st. And the second parameter will be the actual type of the function, right? So we will say like expression type. And this will be like a span, like callee span, which will actually be a text span, and this will be callee type. Yeah, cannot call non-expression. Cannot call non-callable expression of type. Blah. Yeah, that will work. Cool. So, yep, that works. Nice. And now here we can say like, I don't know. Probably have to get the span here as well. Right, and then we have to change that. Take in like a callee span, text span. So we can just say callee span clone and callee span literal. Oh. What the hell happened to this letter? Okay, interesting. Okay, so we don't need our global symbol resolver anymore. And when running, we don't actually want to look for a function called main, I guess. Could probably look for a variable, global variable called main. So call this main function ref, and say a function will be match. You could say like function is self global scope. The variables get function, and we can then say let function is match function type, and if this is of type function, we could then return the function. And else we could just panic for now. I know it's not the best way to handle this error probably, but it's fine for now. All functions get index. Okay, so we have to key reference that. And instead of visiting a statement, we will visit an expression. Bop. Okay, so we'll probably have to create the global scope ourselves now. So we have to say global scope new. Okay. Nice one. So now it's time to adjust the evaluator. So this will be func x and func x, and this will be x by d, x by d. So right now we don't do anything if we encounter a function expression. But what we actually want to do is we want to set our last value to the reference or the function index, right? But right now our last value can only be an I64, which is bad, right? Because we probably actually somehow with like unsafe code could probably do that, or we could actually do that altogether because our function index is just a U32. But I feel like that's just bad practice, right? So what we could actually do is we could create an enum, and this enum would be called like, I don't know, enum value. Probably has to be public. Pub enum value. So this could either be a number or a boolean, or right now even a function. So this will take a function index. So this will hold our value, and if our boolean instruction, we probably don't even need that anymore. Cool. And so because we didn't have our value enum before, everything was just an integer. So also boolean values were an integer. So false is like 0 and true is a 1. But now we have like actual typed values. And what would be nice, instead of unwrapping our last value every time, we could just say like, I don't know, fn expect last value, and we can say should be a return value, and we can just unwrap this, right, and return a reference, and we can actually provide a message here. We can say expect the last value we set. Right, okay, cool. So we can now say self expect last value. But now we have a problem, because how do we get to the underlying data? So of course we could do something like, I don't know, probably even match this in here and say like, okay, if this is of type boolean, we will return the value. If not, we will panic. So, but you can imagine that this will be needed like a lot of times in this evaluator. So we can actually just create a method on our value enum. So we can say impl value, and we can say like fn expect bool or boolean. And so we will just panic if we don't have a boolean. We can do the same for a number. So we can say expect number, and we can say expect function. Cool. So now instead of this madness, we can just say self expect less value and expect bool. And we can do the same for our if expression and for our, let's say, banana. Okay, so now our last value, as we just said, is no longer an I64, so we also have to adjust our frames. Up. And those will now also take a value, or return a value here. We'll also expect a value here, and in our frame or our hash map will also hold just a value, not an I64. Up. So same here. Blah 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 blah. Okay. Type void cannot be reference. What are you talking about? Okay, cannot move. So this is because we don't have derived copy for values. We can do that by clone and copy. And copy is a good choice here because our data is relatively cheap to copy, right? So it generally is a good idea to implement copy or derive copy for all types that whose size is like less or equal to the pointer size. And pointer size is usually like 8 bytes, and I64 is 8 bytes, a boolean is one byte, and a function index is also just a I think a U32 or U size, probably U size, so also 8 bytes. So we can derive copy from that, for that. Type. Wait. Oh. What does that star do here? Okay. What does that star doing here? Alright. So now, when calling a function expression, probably have to do like the same logic as in our compilation unit. So now instead of looking at the function by name, we will just expect that the callee of the call expression is of type function. So we will say match expression of type, and if we are of type function, say function index. Otherwise we will panic. Expect function type. Yep. That's actually pretty simple. And that's all we had to do. Now we can just visit an expression here instead of statement, and we're done. And now we just have to adjust like the problems with, or like not a problem, but the fact that we just have introduced a new type called value. So instead of passing an I64 directly here, we will pass a value number. So to say that our last value is now a number. And instead of casting our boolean to an I64, we can now just say, I want this value to be a boolean. And for unary and binary expressions, this will be a bit uglier, right? Because for our unary expressions, it's quite okay, because everything, or like every unary expression that we have right now, just returns an integer. So just because we just have bitwise, not a minus, right? So what we can do here is we can say expect less value at expect number, because all of these unary operators just accept numbers. And even more, we can now wrap this inside of a value number, because we always expect a number here. Now, here comes a problem, right? We cannot do that for our binary expressions. And why is that? Because our plus expects two numbers and returns a number, but our equals or not equals, or even worse, or less than expects two numbers and returns a boolean, right? So for example, for less than, we would have to do something like this. We would have to say value, what value, like what type do we expect? We expect, or we want this to be a boolean. And this should then be like left expect number, because we expect left to be a number. And this should then be less, and right expect number. So this is kind of verbose, but I think it's pretty nice to have like decent value typing, so we always know what we're working with. And for plus, this will be like value number, and left expect number, and right expect number. So for this use case, GitHub Copilot is just great because it can just go ahead and just move the line and let it auto fix for me, right? Okay, this is not correct. We don't want to do that. I have to cast this to U32 because Power expects U32. And now we have to say bitwise n should also be a number, bitwise or should also be a number, bitwise XOR should also be a number, equals should be a boolean, right? Boolean, and it should be like left is equal to right. Same for not equals. For less than, we have already implemented that. Less than or equal, greater than, and greater than or equal. Okay, so binary operation blah cannot be applied to type value. Okay, makes sense. Because for value we have not derived partial equal, right? So we can do that. So now the comparison will work. Let's see, maybe our program will even compile. Duh, okay, it will not. Printer, okay. Func expression, and we are also missing expression ID here, and we don't have an identifier anymore. Now we can say that decal is func expression decal, and we can say like decal parameters is empty. Decal parameters header, okay, that's fine. And decal body visit expression. So this should work fine. Let's see. Okay, visit. No, we want to visit an expression, and that expression will be our call expression dot quality. Here we go. Okay, let's go. Okay, wait. Oh, we have to pass our AST as well. Okay, what do we have here? Immutable borrow occurs here. Okay, so this expression comes from a function that borrows self immutably, and we use this expression here, and we need to borrow immutably here. So that is a problem. We could fix this by just saying, okay, just take the ID here. But then we would lose the ability to return a reference to expression here. But I think it's kind of an n-type pattern we're doing right now to just return a reference to the expression, because we could also just return an expression ID, right? I think that's makes the most sense, because that's what we're returning or like using from every like parse call anyway. So for example, I don't know, like in a parse if expression, we parse an expression and just use the IDs anyway. So why not just return the IDs? So we can expect an expression ID here. Same here. And now we will have to add ID here and ID here. Probably don't even have to do that. We can just change the return type, and we can also change return type for that function, and we will do that for every single function. And now we don't even have to query, we can just return left. No ID here because, okay, yeah, well, my bad, we need an ID here. Change that, return type, below, return an ID here, remove that. Primary expression, okay, that's working. Don't need an ID here. What are you complaining about? Parse call expression, right. Okay. Can remove that. Need to return an ID here. Can remove that. Can remove all of those ID stuff. Also here and here and here and also here and here and here and here and here. Cool. So let's run this or not. Okay. Cannot borrow self is mutable. Okay. I guess this makes sense, right? I guess we could also just copy this straight up, right? Because why not? Oh, it's running. It's running. Oh. And our parser seems to be broken in some sense. Okay, so we expect this in front colon. Oh, I see what's happening here. I think we may have forgotten the func keyword. Now let's run this. I think the expected result would be 50. Let's see. Yeah, okay. Cannot call a non-callable expression of type resolve. This makes sense. Because I think we forgot to resolve the type here. Right? So before entering the function, what we can do is we can say AST set type for expression ID, and it should be type function and function index. So this should work now. It doesn't. Wait. What? What? Okay. Why? Just why? Why are you not working? Cannot call non-callable expression of type unresolved. Okay. So this is parsed correctly, right? Did I forget to specify return type? No. Okay, let's just submit it here. Okay, that's fine. Why is this unresolved? Huh. That is actually interesting. So let's see, where do we set the type? We set here after creating our function, because that makes sense, because before that we don't even have the index. Resolve type from string, declare variable. Okay. Makes sense. Huh. Is this expression ID the correct one that we pass in here? Expression.id. Yeah, it seems correct. Okay. That is actually an interesting one. Okay. So let's take a look at our call expression. Maybe something's wrong here. Okay. Right. This makes sense. We cannot match against the type of the expression because the type of the expression is the type of the call expression. But the type of the call expression obviously has not been resolved before we have even visited the call expression. So this needs to be the type of the callee. So we say callee, and that callee is a C query expression callee. Cool. So third try. Third time's not a charm. Right. Yeah. And it is still not working. Oh, okay, so we still pass the wrong type here. C. And still unresolved. Callee type. Oh, okay. It is obviously unresolved because we have gotten to visit the callee beforehand. Okay, so I think that just shows us that our current structure of like type resolving is not the best, right? But I think it will work now. Hopefully, please. It almost does. Okay. Probably the same mistake in our evaluator. Yeah. Okay. Let callee have to query our callee. See query expression, and we don't have. We mustn't use our expression type here, but rather the type of the call. So this should work, please. Yes. Okay. Cool. Returns 50. Let's go. Let's go. Oh. Oh. Okay. Now let's do some like more complicated testing. So what we can do is we can try to declare a function, or like have declare a function instead of another function. So we can say something like let mul is we take an integer a and an integer b, and we return something of type integer. And we will use a helper function called add. And how you multiply? Well, only using addition. You use a while loop and a sum variable. Set sum to 0, and then you say while b is greater than 0 or in, doesn't really matter. We say sum add sum and a, and we decrease b, and we can say return sum. Now let's see, will this work? Leave your guess in the comments or in the chat. I believe it should, but could also probably fail. So let's call that, and let's calculate what the result should be. So a is 10 and b is 20, and we multiply a with b. So 10 times 20 should be 200. Stored in c plus d is a is equal to b, then it's 10, a is not equal to b, so it actually is 20, right? That means that it should be 220. Let's see what our result will be. Blah, blah, blah. Cannot return, use return outside of function. Duh. Okay. And that is in line 13, which is probably that return, right? Yep. So something is not working correctly with our scoping. Let's see. Okay, that makes sense, because right now we only have like a single property on our scope struct, which says if we insert a function or not. So like what happens is, let's open up main or rs once again. So what's happening is we parse this statement, we go into this expression, and we say, okay, now we're in a function. So we set our surrounding function property to the index of that function. And then when we leave that function, we set it to none. But because we're already in the outer function, we don't reset this value to be now have the value of the outer function. And so it's just none. And so it thinks we're not a function here. To fix that, we should probably introduce a stack of function indices, right? So whenever we enter a function scope, we can just like push a function index onto the stack. But I don't think I want to introduce a new stack. I think we can just say like function in our local scope, because each local scope can have a function, right? Can have a function, or like each function has a local scope, so each local scope can have a function. So I think it makes sense to include this here. That would mean that we now have to pass function here and here. And we can remove the surrounding function property. That was the wrong one. And now when we say enter function scope, we say we could like say local scopes push local scope new, but that would mean we have duplication. So it just create a private method called underscore enter scope, and let's pass some function indexing here. And then we will create a new function called enter scope, which will take a function index, which will be option of function index, and will take mutable reference to self. And this will push a new local scope with the corresponding function index. And so in enter scope, we just call enter scope with none. And now we have a nice little helper method, and we don't have any code duplication, right? So, and now if we exit a function scope, what we can do is, before actually exiting the scope, we can probably assert that we actually exiting a scope that contains a function. So we can assert that self local scopes plus unwrap dot function is sum. So that's just practice, right? Because then we'll immediately know that something is wrong at this point. And our surrounding function will now not be the surrounding function property on our scope struct, but rather we will now have to walk our local scopes and let's say iter the ref. So we walk backwards, and we will say like find. We'll find. Yeah, find till. I think that makes sense, right? So we say function is sum, then we have this local scope where the function is sum. So we say like local scope, and now what we can do is we can look up the function by saying local scope function unwrap, which is safe because we know that it is sum. I don't know if there's a better way to do that, because that is kind of ugly, right? Because we say is sum and then unwrap. I don't know if there is I think there is like filter map, right? Is there like The last map? I don't know. Maybe we could use a filter map and then just take the last value. I guess we could do that. So we can say filter map and we will map to the function. And then we will take the first value, right? We will take the first value. Does that work? First last. Do we want to take the last value here? I mean, you could take the last value. Where's it called? Head. I don't know. Like, okay, we could say like next. And I would map that. Okay, I think that is pretty cool. Or not pretty cool. It's cool because we don't because we don't use any unwrapping. I mean, instead of like reversing here and saying next here, we could probably also say use last without reversing, but I think it's fine. So maybe that will fix our problems. Let's see. Okay, so now we compile, but now we say variable b not found. That is interesting. Variable b not found. So where does this happen? Okay, visit variable expression. So I suppose it could either happen here or here. Alright. So let's check if it happens here. How can we do that? I mean, we could look at the stack trace. Maybe it gives us some hint which expression we visited. Variable expression. Huh. Okay, we were in a binary expression. For that, we were in a while. Okay, we were in a while expression, so it's the second one. So that is actually interesting why our variable b is not found there. I mean, let's just go into visit while statement and here and just debug our current frames. So we will say debug. So if you don't know about the debug macro, it's pretty handy. It just like prints out the debug representation of the object you pass in. You will see that in a second. So frames does probably not derive from debug, so frames will need to do that for us. So derive from debug, please. Thank you. And frame also need to do that, and value already tells. Okay. So now you can see it just prints out the debug like string representation of the object. And you can also go to like the point in the source code, source location where it was printed, which is also pretty cool. Okay, we see a variable with index 8 is declared. Okay, I don't think that's enough what we're doing here. I think we also need to print all our variables. So yeah, okay. So we have two variable symbols with the name b. I guess we should have 3, right? 1, 2, 3. And do we have the, yeah. Okay, so a variable is properly declared, but it is not enough frames, right? Okay, so we don't see the index here. The index here is unfortunate. How do we see the index? Okay, we can just count, I guess. Okay. Before that, we will probably need to figure out which index is actually going wrong here, or not, is not found. So we can just also print that. Just say, I don't know, like this, identifier at var x odd variable index. Just run this again. Okay, you do not implement display, which is fine. So we just say as index. Bats. Okay. Variable 5 not found. Okay. So we're looking at variable with the index 5, which is 1, 2. Oh, we're starting from 0. I'm sorry. 0, 1, 2, 3, 4, 5, which is B. Okay. Looking at variable index 5. So 6 and 7 are declared. 2 and 3 are our scopes. No 5 though. Huh. But we do push them, right? So this should happen here. We say self scopes, current local scope, mute, locals push. What happens here? Okay. I see what's going on here. So the problem is that when we declare a variable and we are inside of a local scope, we don't want to declare the variable as global. So what does declaring as global mean? It means that the variable index is pushed to global variables. And because when we declare our variables here, we are not inside of a scope, right? Because we just enter the scope here. So what happens is that these variables, are declared as global. Which then means that if we try to look up a variable, like if we try to look up the variable b by its identifier in our code, we open that. What happens here is we try to look up b by identifier, right? And like when resolving. And what happens is that because we support shadowing, we first take a look at the variable b that is closest, like the closest declaration to its use, right? So in that case, that would be this one. But as we have just seen, this variable is declared as global, right? And we have entered this scope before. So I think what is happening is that we try to reference this b that we try to reference here is actually like this b, but you obviously don't have a value for this b here because it has never been set. So we don't find a value. Something like this, right? So what we could probably do is we could go here, and when declaring a variable, we could like just pass a flag here like is global, and that's actually the wrong direction. Okay. So like that makes no sense what we're doing now, because we try to figure out if we're global here, and then we just override it with this value. So I guess what would make sense is to have like a more internal low-level function that has this signature, and then we call the new like more low-level function from inside this function passes global with like is inside global scope. No, right? Does that make sense? I feel like it does. Okay, so let's just copy this. I like to prefix like those functions with underscore. So what we can do here is we can now we can use our own little helper function self declare variable. Remove that, and is global is now just if we're not inside a global scope. And here we can do that. And here we say is global. And now instead of using this function here, we can use this function, and we say false, because we're never a global scope when we declare a parameter, right? Now let's try this again. Bam bam. And it returns 220. That's beautiful. Really, really nice. We can remove those debug statements, right? Blah, 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 blah. And I don't know what to do next. I guess we could like test this even more. We could make this recursive. I think like recursion is often like a source of bugs for like compilers, right? Because they're kind of like recursion is just kind of weird, like especially if you get into working on the stack and stuff. You can like, easily just override locals from the stack frame where you're calling the function from. But we don't have that yet, so we don't have to worry about that. But it would still be nice to test recursion. And so why use the built-in add operator when we can just implement it ourselves with a while loop, not while loop, recursion. And how do we do that? We could do that by saying this should be like help add is what could this be? How do we implement an addition recursively? I guess we can say like func it will be like a, and this will be like I don't know, runs int return int. And we will say if runs is equal to 0, return a. Else we will return h add with like a. That makes sense. I would just pass A here, right? No, this makes no sense. We would pass like 1 here, right? So runs B. So B times we add 1 to A. Makes sense. So let's see if we still get 220. Right, okay. Makes sense. Blah, blah, blah. Undeclared variable h add. Okay. So recursion does not work. That is good to know. I think I already know why. So, why doesn't recursion not work? That is because we reference this function by name, right? And the name is not resolved here. It's not resolved when we parse the body. So we can see that here. So this function is called when we try to resolve the expression, the initialization expression of the let statement. And we then visit our body. But the body is then visited before, like here. So that is the initialization expression, which in this method call also the body of the function is visited. And we set the type for, or like we declare the variable here. So after we have visited that expression. Okay, so let us think of a not too dumb way to do that, right? I mean, it makes sense to like not be able to do that, right? But it also doesn't. That's an interesting problem, actually. I'm glad we have tested this. I mean, I don't know, like, I just know, like, a technique like this from OCaml, right? When you declare a recursive function, you something like that. So let rec, but that would not fix our problems, right? So, like, we kind of would have to account for this special case where we need to know that our function exists before we actually like have resolved it. So like one option would be to like just remember every time we have encountered a function or like an unknown function, and then resolve it like after we have like after the first pass, right? So because after the first pass we know which functions exist. But I feel like this would also be kind of bad, right? another. Oh. I think I know what we can do about that. I don't. Oh yeah, I do. Okay, so there's two options here, or at least I can think of two options. So the first option would be to like kind of make this resolving process, give it more context, right? So when we declare, or like when we parse the initialization of a let statement, we can just set a property of in our resolver. Okay, this is the variable name, and then we can use the surrounding function property, which is set, to check, or like we could check all surrounding functions inside of a function and check if like any of those match. Does that make sense? I don't really know if it does. Does it make sense? I'm not sure if it does. So what I mean is that when we're inside this function body, before trying to resolve this, we set a property on our resolver, which says, okay, you are now resolving the body or the initialization of a let statement, which could potentially be a function, like a named function. And so if you encounter this very name while resolving, it is a function, and you can call it recursion. That would be option one. Let me think about what could go wrong there. I guess we'd have to use a stack as well, because we can't just have one single property, because the nested recursive call, so a function instead of another function which are both recursive, would not work. I mean, when calling this, we know the signature because it is provided here, and we know the name. Guess that could work. So that is option numero uno. And the second option, which I actually kind of like, could also lead to problems, is like kind of using a specific syntax or introducing a new keyword for doing recursive function calls. So we could say, instead of hadd, we could say rec. And rec would be a keyword, and when using a rec, we would then automatically resolve this to the surrounding function, which we know the index of and stuff, right? Problem with that is that, for example, what would not work were like nested recursive calls. Like, okay, it would work, but what would not work? Imagine this. We actually like have another function in here. I don't know. Could be anything. Doesn't really matter. And now in this test function, what we want to do is we want to call hadd, right? But if we now call hadd here, like with, I don't know, 1 and 2, this will not work, right? Why will this not work? Yeah, so like for the exact same reason why this doesn't work. Because HAdd is just not known here. But if we now wanted to call that, it would not be possible, because if we now use rec, that would not refer to our HAdd, but to our test. To be honest, I don't know, like, would that even, like, break? That would so break stuff, right? That would break stuff. Oh, no, it wouldn't. I guess this approach is cool, but I feel like it is harder to implement and doesn't like support everything the first approach does. So with the first approach, I mean like remembering somewhere that we are parsing a potential named function declarations. What would be cool about a rec keyword? Oh, we could also add that, right? We could like do both, because what would be cool about a rec keyword would be that we wouldn't need like a name, right? We could just do recursive calls inside of anonymous functions. Because imagine we want to pass a function as a value and want to do recursion inside of that function. That would not work. At least like not with introducing a separate helper method, like because the function doesn't have a name. But if we just said, okay, the rec keyword just always references the closest surrounding function, that would work. So for example, if we wanted to pass, I don't know, like some function in here, like func blah blah blah, boop, we could not like reference this function, right? Because it does not have a name. But if we said rec, we could. That's actually a pretty cool idea. I think I like that. We have to think about that anyway, like how we can pass functions as well as values. Because it would like be really bad if we had to specify like, the whole signature every time, right? So we would have to do like kind of type inference. Could get harder than I imagine, but I think that's okay. But let's focus on one thing at a time, right? So that thing is getting this to work. So let me just add that to the list of ideas, right? Add rec keyword that references the immediately enclosing function, right? Help. Something like this. Batch. Okay, cool. Exactly. Now let's try to fix what we have. So we say, and we can remove that and replace that with P. And it still doesn't work, right? Okay. So in our resolver, we will need to add a stack. Probably even do that in scopes. could we? Nah, it's actually gonna think for resolver. So this will be. What will this actually be? It will be. Enclosing variable declarations, and it will hold strings, like just the identifiers. Is that a good idea? I don't know. I don't know if it is. Is it? Is it? I don't know. What we would not want to work is something like, I don't know, let's see is equal to C. Right? That would be like really bad. That would actually work. Oh, didn't mean to close that. So our enclosing variable declarations. I don't know if that makes sense though, right? We could like say closing function declarations. I mean, okay, so we could remember like every variable declaration that we encounter and then go into the initializing, and then when we're actually in a function expression, we could like interfere with that. I guess that makes sense. Okay, so we can just do that for now. Enclosing variable declarations will be an empty vector. And what we now can actually do is we can go into our a local scope, and instead of just storing our function here, we could also store its name, or like, yeah, its name. The thing is that we don't always will have a name, right? So this will be an option. This will be like enclosing variable declaration. Right. Okay. So we will have to update that, a closing variable declaration. And we will have to update that as well. Like none. And closing variable declaration. Okay. So now in here, when we say we have a enclosing variable declaration, could say like last clone. I think that will work. Okay, so we have got this. Okay, so now we somehow have to do something with the information that we have just gained by it. What could we do? And surrounding function. Okay, so we could say like fn find surrounding function by name. Okay. Do that. Say find surrounding function by name, which will just filter map, find. Could probably do that to improve readability a bit. Okay, makes sense. So you try to find our surrounding function by name. So where do we do that? So first of all, let's push every time we actually encounter a variable declaration. So here we can say self closing variable declaration is push identify clone, and here we say pop. Cool. So we have now we have that in our variable expression. What we could do is, like, if we say look at variable and we have none, we could try to say let enclosing function is self scopes find surrounding function by name. We could say, okay, help, did not mean to do that, sorry. What we could do is we could say let's take this literal and extract it into a variable and say this will be variable name. Now we can use that here. Variable name. Okay. So if we find an enclosing function, what we can do can we do because we somehow have to also set this variable index, right? So we somehow have to know the variable index before visiting. Okay, let me just check if we can do that. Like if we know, or if we could declare the variable here. Okay, we could somehow, like with modifying the type after we have declared it. That's just bad. Okay. We could also just disallow recursive function calls. I don't know. Like, what do we do if we find a surrounding function here? I mean, that's pretty cool that we found one. But I mean, we know the type of the variable, but we don't know its variable index. So I guess what we could do is we could say matching closing function. Matching closing function. If we have a none, we can do that. We can report an error. Up. If we have a function, so you are our function. Help. We can set the type. Yeah, and the type will be type function ID. We need the ID here. Okay, let's just say function index. So let's just remove this map. We need this map, but we don't like that. Function clone. Try to reference it. Yeah, it's better. Okay, so closing function. Cool. I feel like this could work. I feel like it will compile, but throw an exception at runtime. So I already have a solution in mind, which would include like remembering that we need to set the the variable index for the specific expression. And we can do that after we have created the variable. But let's see, maybe it just works. I don't know. Maybe some dark magic. Actually it does. No, okay. But no, this doesn't compile, which is fine because we have just included that to see if it make sure it doesn't work. Okay. Thread main has overflowed its stack. Yeah. That's usually not a good sign, right? Why does this happen? Okay, so we say add. Maybe it's just an error in our logic. And to be honest, I don't think it is. Oh no. I don't know. Let's see. Let's run this in debug mode. Alexa? Help? Expression? Okay. So it is an hour. Evaluator. Is it expression? Is it if expression? Is it return? Is it return? Expression? I don't know if it has something to do with the variable index not being present. I feel like it could be. What is the default value anyway for our variable index? Like if it's 0, that could be bad. That could be like really bad. Oh, I think I know what the problem might be. No. Okay, I actually don't know. I actually don't know. I don't know, maybe let's just try to apply the solution that I had in mind before. Maybe that works. If it doesn't, I'll be sad. But I guess that's fine. Maybe we'll just have to add the rec keyword. Okay, let's see. Compilation unit. Set variable. Okay. What is this variable index in the beginning anyway? Okay, it's 0. Okay, let's try to do what I had in mind. Which is like, we will say something like self dot okay, wait. If I think about it, that is also bad. Why is this bad? This is bad because if we shadow declarations inside of declarations, which we can do, that will not refer to the correct surrounding declaration. I'm starting to feel that it would make more sense. It would make more sense to to create this variable like beforehand. So like before we visit this expression, and then just set the type for the variable afterwards, right? So we just declare the variable with identifier and type unresolved. Because that would mean that we could actually look up the variable like inside of the body. It would like just be unresolved, right? Type. I feel like this would be a better solution. So how would that work? So we would go up here and say something like this, and we would not need this enclosing variable declarations anymore. That does also mean that we don't need this anymore, and just have a function index here. So this will just be function. This can go away. We don't need you. We don't need you. We don't need you. And we don't need you. And that can go back to just being function. And this can also go away. Find surrounding function by name. Just delete the whole method. Enter function scope. Right, we don't need that. Go away. Right. Okay. Move that. And just replace the whole match segment with this. Cannot find type. Okay, that makes sense. And we just say type unresolved. I think the thing is that in case of a function, we could probably actually know the type, right? Okay, let's see. Because now we can say self scope set variable type. That's what we type. Okay. Set variable type. Just implement this method. Set variable type. Cool. It should still not work. Oh, we should get a different arrow. The arrow now should be that we cannot call we cannot call a non-callable expression of type unresolved. Yep, exactly. Okay, that is much better. We can fix that. And I think that we even get the same. Should get the same arrow for something like this. Like that C is equal to C. Hopefully. Okay, that's interesting. I think we have just introduced a bug, right? Because what will not work anymore is let C is equal to 10 and let C is C plus 10. Does it? Yeah, we can test that. We can test it by saying let B is B plus 10. So now we should get like instead of 220 as a result, we should get 320. Let's actually make it 20, so we get 420. Badoosh. Right. And now we somehow have to resolve the type. And to be honest, I think here it would be like pretty great to already have a good type system with like constraint solving, because then we could just add a constraint here and say, okay, we want this function to have this signature, and then later in the second pass we can say, okay, yeah, that's fine, this function has that signature. But I feel like for now we have to do something like like really bad. I feel like I could do something like really bad here. I think what we could do is we could reintroduce the concept of this enclosing variable declarations concept thingy, but now we have the variable index, so we don't have problems with like shadowing, and we could then try to do that. Yeah, I feel like that might be it. I think that's it. I think what we could do is we could like check the type of this expression, right? And we could say if this expression is a function expression, we could just take its return type, right? We could just take its return type and set it beforehand. Or we could just really... I think that's just also complicated. Right? I mean, that's... You know what? F this. We will not do that. What we'll do instead is we will introduce our rec keyword, right? I kind of like the idea. So how do we do that? We say, okay, let's create a new token kind, a keyword, and this keyword is called rec. Rec will be rec, and it is passed by saying rec, token kind rec. What are you complaining about? Yeah. Cool. Okay. So rec. We will need to add a new expression to our add state. So we will say like rec x. Kind of sounds like regex, but it's fine. And rec will like literally do nothing. So rec is just, I don't know. Rec. Keyword. And okay, we don't really care about tests right now. So we have this. Now we have to add this to our visitor. Rec, bam bam bam. Visit rec expression. Da da da. Fn visit rec expression. Expert ID, expression ID. And this will be our rec expression. Expression ID. Okay, cool. So now we have added that. Next up, compilation unit. I will just quickly steal code from return statement. Do something like that. And say, we will need to implement this new function. And we say, if our surrounding function is none, we cannot say, I can say like, import cannot use rec outside of function. And we just say expression, rec keyword. And here we'll say, this expression will be of type surrounding function index. To create a new method for that because we need the index. And we will just say ast set type function. Cool. So two functions that we need to create. Surrounding function index should be straightforward. Surrounding function index will probably just be that one. So we will say extract this method and we say surrounding function index. And we can actually copy this So this should work here as well. Diagnostics back, blah blah blah. Can use rec outside of function. Okay, cool. I think maybe this will work. I'm not too sure. Yeah, let's see. So we will add rec here and rec here. No, not rec here, just here. Please work, please. Oh, yeah. Rec. What do we even do when we see rec? Always say self as value. AC. That expression. That function is expression type. Match expression type. And no, we can say function. Function. Let's see. Please. Oh. Okay. Printer. That will be relatively easy. Blah. Just add a rec keyword. Okay. Expecting expression for rec. Okay, so we have to parse it, obviously. Parser. Okay, so. That will be a primary expression. Primary. Parse primary expression. So we will say token kind rec. We will not record rec. We will just say this expression will be self AC rec expression ID. Right? Yeah. Okay. So rec expression. Just add that here. Rec expression. We don't need a body. Body. Cool. Verify. We don't care. Please work. Whoa, wait. Okay. Thread main has overflowed as stack. Shut up. Why? Oh man. Okay. Let's just see this. Okay. How do we debug this? Could actually probably maybe go into our evaluator and just debug stuff, or like see if we use a rec expression, right? So we can just set a breakpoint here and debug this. Wait, calculate layout for. Wait, what? HashMap. Wait, what? What is happening here? what? When we try to insert here, what is value? Coordinate value, DW entry value, okay. So when we try to insert a value here, the value just grows. Wait, what? Value cannot calculate layout for it. Okay. Like that is actually interesting. What? Why does that happen? How can that happen? Like our value, what does that say? Bad access, okay. You uninitialize. Unsafe, okay. I hope that this is not a bug within like the hash map, right? That would actually be funny. That can't be right. Is this unsafe? Okay, it is. I guess it could happen, right? Because we're inside of unsafe rust here. But it obviously should not happen. We try to insert an argument. So what is our argument? Not a number, a boolean, or a boolean. And it can't? What? It cannot calculate the key or something like that. What does it say? Bad access, okay. What is happening? Resize hash map. Okay, this is actually funny. I mean, what we could try is we could just not use a hash map. I feel like we could do that. Just do a vac here. I don't know if that will fix like anything. I mean, we could probably like calculate the size of the vector beforehand, but I feel like this is not necessary right now. So we could like variables. Resize. Yeah, I guess okay, that's cool. And now we can say something like I think that would work. If frame variables. Cool. See. Now we actually don't overflow the stack. Maybe that should be reported, right? I don't know. I mean, I have the vault, right? So I can, like, just try to get back to the code, which like introduce the bug, I guess, so they can replicate it. Maybe I will report that. I don't know yet. But the problem is that 20 is not the right answer, which is kind of unfortunate. Let's see. It almost seems like Z is 0 here. Kind of has to be. Let's see what is 0. What Z is. C is 0. Okay, why is that? Why could that be? So while b is greater than 0. Okay, let's just say sum is equal to b here. Okay, that is kind of a problem. Why is that happening? So if the sum, okay, because it's set here, right? What happens if we return a here? Set 20. That should not happen. Because if we return 20 here, 28, it should return 10. A does, okay, no, A does not equal B, right? No. So this is 20 and, okay. Let's see, what is the value of A? A is 10, okay, makes sense. What is B? B is equal to 20. That is also kind of interesting, because we obviously have set B to be B plus 20, so it should be 40. So, okay, so something is not quite right here. To be honest, maybe the wrong values are modified. Maybe that's the problem. I mean, this B obviously has to be 40, so that's like the first issue. Why is B not 40? Let's remove all of that and see if B is 40 now. Okay, still is not 40. Okay, so if we say B is 10, is it 10 then? Okay. So shadowing just doesn't seem to work. Why is that? I mean, that would be a problem with like lookups, right? There could be a problem with the order in which we look up global variables. So let's check that. That would be in our scopes. So we say lookup variable, lookup global variable. Yeah, okay. So we have to obviously say ref here. And now show at least just 40. Okay. That is cool. It still does not explain the problem, because 40 is like correct, but E is still wrong, right? Yeah. So E is still 20. So C is still 0, which is not correct. Like what happens if we return a constant value here? It's 30. Now it should be 40. Okay. Now it should be 69. Nice, okay. kind of feels like that A is modified in the wrong way here. No, actually that's not true. Feels like B is. Let's see. Do we ever enter the loop with a while statement? Can I say? Okay, that would be wrong, right? Yeah. Yeah. Okay. That's correct. Let's set a breakpoint here. Okay. We actually just never entered the loop. Wait, what? Why not? While b is greater than 0. Expect boolean, expect last value. So this should be true. So let's see. Greater. So we say value of boolean will be left is greater than right. B is greater than 0. Left is greater than right. Yes, seems correct. Seems correct. Okay, why? I thought that we would not revisit the condition. So let's see, what is our last value? False. What? Okay, let's investigate that. So we go into here, go into here, go into here. Now let's see what left and right are. Left is 0. Left is 0. Okay, right is 0. Okay, so at least that's correct. But like, why is left 0? Why are you 0? Please do not be 0. Why is B 0? B is on 0. B is here. B is 40. Not 0. Okay, I don't know. I don't know what that could happen. Okay, let's go in here and check. Let's set that breakpoint when we actually want to visit the binary expression. So that will be now. So we say there's a binary expression. We go to the next breakpoint. Why did it not save the breakpoint? That's unfortunate. Hello. Okay. Visit binary expression. No, breakpoint set. Go. Cool. Okay, so we go in here, we go here, we go here, variable. Okay, so what is this expression? Variable index is 4. Oh, it could be because of our new scoping. I'm not scoping, like value handling without the HashMap. Right. that could actually be the issue. So let's stop this. And let's see. Where's our frame? Okay. Resize. Oh, okay. No. No, I think that's correct. What? Okay, let's debug this again. Let's just take a look at the actual frames, right? So okay. So we were taking a look at 4. Okay, that's wrong. So do we find 40 here anyway? Anywhere. Okay. So we do have 40. So I still want to, like, why do we only have 1 frame? I guess that's wrong, right? Why do we only have 1 frame? Oh no, we have more. Okay. So this should be the frame with like our variable, our parameters. So it should probably be somewhere. It's actually nowhere. Okay, everything is 0. Okay, no, it's not true. So it's a 10. Okay. Why is it a 10? So when we visit our call expression, we insert the variable index. Okay. Okay, let's see what is happening here. Okay, so frames empty. Makes sense. Valid. Cool. Param index 3. So what is happening? Oh, okay, so that could also be like quite an issue because our variable indices are not like scope specific, right? So they start from 0, like for every no, they do not start from 0. That's a problem. They do not start from 0 for every new frame. So like imagine why we could get Stack Overflow there, or like why we would use very much memory, or a very large amount of memory, because like imagine our B has a variable index of 12, because that index is just increased every time a variable is created, and the index is not scope specific, so not for every scope it starts from 0. So what happens is that we create space for 12 variables, even though we only need like space for 2. So that's pretty bad. not sure. I mean, like, the HashMap was just good, right? I really want to use a HashMap, but I don't know. It just kind of did not work out, right? Let's just try it again. Maybe a compiler likes us now. I don't know. Damn. Okay. It doesn't work. And I don't understand why. So do we ever get into the loop here? Okay, now we do. Like, on the first exit, we just crash. What? That is pretty bad. Okay, I guess we cannot fix that now. So I guess we will do that next stream. Right, so maybe we will need to use like an external HashMap. I don't know, something from crates.io. Okay, we'll have to figure that out, or maybe you guys have an idea why this is failing. Yeah, so just let me know. And I will now just push the code and merge it, I guess. Yeah. Say make function values, and we will push this, and I will merge the branch. And I guess I will see you next time. Have a good time.